Okay, today we're going to be describing quadratic solutions without actually finding them. And we'll break this down as we go along. But I just want to review a few things with you. Now remember, the number of solutions in an equation is determined by the degree of that equation, which was the highest exponent. The solutions are the x-intercepts. We also call those the zeros or the roots. Those are interchangeable. All three are interchangeable. And remember, the standard form of a quadratic is this. It says ax squared plus bx plus c equals 0. So your exponents go downhill, the descending order. Now, in Algebra 1, you should have seen at some point the quadratic formula. So let me remind you what that looks like. Quadratic formula looks like this: negative b plus or minus the square root of b squared minus 4ac divided by 2a. Now this is something you're going to want to memorize. You don't have to have it memorized tomorrow or anything, but you are going to need it memorized by the time we take our test. So we're going to break it down into parts. Today we are looking at just the discriminant part of the formula, which is this part right in here. That is the discriminant, okay? That b squared minus 4ac is what's underneath the radical. And that's what we're focusing on, because from that information we can know a lot of things about our results, okay? So let's look at this. If you run through the numbers and you get a discriminant that is positive, that means that there are two real number solutions, okay? These are the easy ones, the two real number solutions, which means, it crosses the x-axis in two lovely places. You can eyeball these, okay? It could open up, it could open down, but either way, it crosses that x-axis in two places. So those are two real solutions. That's when it's positive. Well, what if it's negative? If what happens underneath that radical comes out negative, that means I have two imaginary solutions. Okay, remember, imaginary solutions don't ever touch that x-axis. They could be up here, they could be down here. It can cross the y-axis, but it would never cross the x-axis, so don't let that trouble you. Well, then what if what's under the radical is 0? If it is 0, then that means that there's one real solution, but it's a double root. One real solution, double root. That means that's the ones that kind of sit on the axis. They kind of bounce off of it. It could open up, it could open down, but either way, it never actually crosses it, it just bounces. So knowing those properties, we can then use the discriminant just to make descriptions, okay? So look at what we're going to do. Look at what the instructions are telling us to do. Your answer should contain the number, how many solutions, and the nature of those roots, okay? The number and the nature of the roots. So let's try some of these out. So look at number 1, x squared minus 3x minus 28. So to do our discriminant, let me rewrite the discriminant really quick right here. I need b squared minus 4ac, right? That's the discriminant part. I need to know what b is. I need to know what a and c are. So a is the coefficient of that x squared, which is 1. B is negative 3, C is negative 28. So I'm going to plug that into my discriminant formula. So negative 3 squared minus 4 times A times C. And I can plug that into my calculator. And when I do, I'm going to get 121. It's positive. So remember, if it's positive, what does that mean? That means there are two real solutions. So I would say 121, two real numbers. That's my answer. Let's try another one. X squared minus 6x plus 9 equals 0. So let's figure out our values. A is 1, B is negative 6, C is 9. So let's plug that into the discriminant. So b squared negative 6 squared minus 4 times A times C. Now you can put that in the calculator, but negative 6 squared is a positive 36. 4 times 9 is 36, so 36 minus 36 is 0. And we said earlier, what if it's 0, there's one real solution and it's a double root. So that's what's happening with this guy. So one real double. I can say one real number and it's a double. That's what I'm going to write for my answer. Let's try one more. 2x squared plus 3x equals negative 6. Now, you notice what happened here? This is not in standard form. It's not equal to 0, so I need to take that extra step and rearrange it to make it standard form. So 2x squared plus 3x, move that negative 6 over, make it positive 6 equals 0. Now I can determine A is 2, B is 3, C is 6. Now, when I put this in the discriminant, I'm going to have B squared minus 4 times A is 2 now, and C is 6. So I'm going to have 9 minus 8 times 6 is 48. That's a negative 39. And we said when it's negative, it's two imaginary solutions. All right, so that's how we're going to do it today. Pretty simple. You're just looking at the discriminant today and drawing those conclusions. What kind of solutions will you have knowing these properties of discriminants? Good luck, and we'll see you in class.